Today we will talk about the law of motion. Okay, so I think we're very familiar with law of motion, especially to the Newton's law of motion. So, law of motion. Before we proceed with our discussion, first uh, let me. Uh, okay, so our objectives for today. First is to describe the inertial frame of reference. And then second is to describe the fundamental forces and the types of contact and non-contact forces. Okay, then we will draw, we'll be able, I hope we will be able, we will also be able to draw free body diagrams and then state the laws of motion. Okay, so I think you're already, as I have mentioned kanina, I think you are already familiar with the law of motion, especially the Newton's law of motion. Okay, then cite and applications of laws of motion in real life and to solve problems related to the laws of motion. So this will be the objectives for today's topic, and I hope we can obtain or attain these objectives. Okay, so before that, I do have an image here. So, okay, describe the image. So, what is your own interpretation on this image? So, the two person has their own interpretation um, on the image or on the number in front of them. So, the white person, so since he sees number 9, so his interpretation is the number is 9. So, si yung black person naman, since he sees number 6, so kanyang interpretation then is number 6. So both of them are correct. Um, None of them were wrong because they only uh, describe what they have observed. They only interpret what um, based on their interpretation. So that is the uh, frame of reference. So the frame of reference is a criteria or stated values in relation to which measurements or judgment can be made. So it is a set of stated values or a set of criteria to which you create your judgment or your measurements. And that judgment or that measurement is it depends on the observation or the interpretation of the observer. So it's based on how the observer interprets. So you conduct or you base your interpretation or your observations on what you see. Okay, so um, you interpret or your observations depends on what you see in terms of your cultural frame of reference. So your judgment or your measurements is based on your own interpretation based on what you have observed or on what you see on that particular situation. So that is the frame of reference. So after frame of reference, so we will talk about the since we are um, talk about forces. So forces, so siguro, when we say forces, the first thing that would comes into our mind is applying push or pull into an object. So siguro that is the first thing that would comes into our mind when we talk about forces. So applying push or pull into an object, but um, siguro hindi lang natin napapansin, but in anything we do, or even we are doing nothing, so we are exerting force. So even though we are just sitting, okay, for example, uh, in this moment, you're sitting on a chair, listening to our topic, or you are doing something, so you are exerting force. So um, you are exerting force even though you are doing nothing. Okay, so and what type of force is that? We'll discuss that later. Okay, but for now, we will talk about how can we describe or what are the words to best describe the word force. So as I have mentioned kanina, intuitively we will think about push or pull when we talk about force, and it can when we are applying push or pull, we are changing the velocity of the object. So it can cause an object to change its velocity. Since we are pushing or pulling an object, then the velocity of that object also changes. So, and force is an example of a vector quantity. So force is a vector quantity. So if we are applying force into an object, for example, if we are pushing or pulling an object, then um, there is a direction in which we are applying push or pull. Either we push it to the left, we push it to the right, push it downward, push it upward. So there is a direction in our movement. So that's why a force is an example of a vector quantity. But based on this, um, based on these descriptions, how could we, or what is the best or the simplest word to describe the word force or forces? So what is could be the best, simplest word to describe the word force? So the simplest word could be the interaction between two or more objects. Okay, so force is an interaction between two or more objects. So if you are pushing an object, so there is an interaction between the object and the person pushing the object. If you are pulling an object, so there is an interaction between that object and the person. So that's why forces is an interaction between two or more objects. Okay, so that could be the simplest word to describe um, force. So what are the fundamental forces? So what could be the fundamental force? The okay, so this time I will introduce four fundamental forces. Um, why does it called fundamental? Okay, we will understand it better later. Why they are called the fundamental forces. So first, let us proceed with the first fundamental force, which is the gravitational force. A gravitational force or gravity. So why is it part of the fundamental force? Because it is the force that pulls us to the surface. So it is a force that attracts any two objects. So we call this attractive because it always pull masses together, including you. So it pulls masses together. including you. So it never pushes an object. So siguro if gravitational force pushes, so I think we are not uh, siguro wala tayo dito sa surface of the earth if only gravitational um pushes masses. So since gravitational force pulls masses together, so it attracts um, masses, including ourselves. So including you, including me. So everything, everyone is pulled by gravitational force. And it is also the reason why the planet Earth and every planet um, is constantly revolving around the sun. So it is the reason why the planet Earth and other planets has its uh, axis, or it has a um, meron siyang gina-follow na revolving point around the sun. It is because of the gravitational force from the sun that pulls the planet, and that is the reason why they are revolving around the sun. Okay, so that is the first fundamental force, the gravitational force. Okay. The second fundamental force is the electromagnetic force. Electromagnetic force, okay, so it is a force that occurs when there is an electrically charged particles. So when there is an electrically charged particles, including the electrons and protons. So when there is an electrically charged particles, a positive or negatively charged particles, such as electrons or protons, and it is also described as electrostatic. Okay, so it is also described as electrostatics for being either positive or negatively charged particles. In electromagnetic force, okay, so we have two types of forces in electromagnetic force. Okay, the first is um, a force that attracts two particles. Okay, the first electromagnetic force attracts two particles. Then the second electromagnetic force, it repels two particles. Okay, so an electromagnetic force attracts particles if they have opposite charges. Okay, if particles have opposite charges, it produces attractive force which attracts both the particles. Okay, so if they have opposite charges, if they are positive and negative charged, so they will produce attractive force that attracts the particles towards each other. But if they have the same charges, okay, if both of them are positive or both of them are negative, they will produce repulsive force that repels from one another. So if they are opposite charge, okay, if their charges are opposite, so they will produce attractive force. But if they have the same charges, so they will produce repulsive force. Attractive force attracts particles, and repulsive force repels particles. Okay, so one example of electromagnetic force is a magnet. So I think um, you have experience doing experiment with magnet or playing magnet. So I think you already saw a magnet, and it's so there are some magnets that attract each other, and there are also some magnet that repels each other. So bakit kaya they attract each other or they repel each other? So it is because of the electromagnetic force. So if they have opposite charges, so they will produce attractive force that attracts each particles. And that is the reason why a magnet, okay, it is also it is the reason kung bakit magdidikit ang dalawang magnet, because they have opposite charges. But if they have the same charges, if they have the same charges, they will produce repulsive force, and that is the reason kung bakit hindi mo kayang ipagdikit ang dalawang magnet, because they have the same charge. So either they are both positive or they are both negative. So they will create or produce a repulsive force. So that is the second fundamental force, the electromagnetic force. Okay? And the third fundamental force is the weak interaction force. So the weak interaction force, or also called as the weak force or the weak nuclear force. Okay, so this is the third fundamental force. The weak interaction, or also called as the weak force or weak nuclear force. So the weak interaction is the reason why there is a fuel on the sun. So the weak interaction fuels the sun. So it is the reason, or okay, the weak interaction is the reason that fuels the sun by initiating the nuclear fusion. So by initiating nuclear fusion reaction, so it fuels the sun, and it is also governs the decay of unstable subatomic particles. So weak interaction or weak nuclear force governs the decay of unstable subatomic particles, and it is also initiates nuclear fusion, which fuels the sun. So that is the third fundamental forces, the weak interaction, or also called as the weak force or the weak nuclear force. Okay? And for the fourth fundamental force, okay, the fourth fundamental force is the strong nuclear force. Strong nuclear force is a strong nuclear force holds most matter. So strong nuclear force is the reason why okay, strong nuclear force is described as it holds most ordinary matters. So bakit? So what is the reason that it is described as it holds most matter? It is because strong nuclear force is the reason that binds protons and neutrons. So strong nuclear force binds protons and neutrons, which forms nucleus. So the strong nuclear force binds protons and neutrons that forms nucleus. So if nucleus was formed, also nucleus also forms atom. And we all know that matter is composed of atoms. So that is the reason why a strong nuclear force is described as it holds most ordinary matters together. Okay? So it holds most ordinary matters together because um, it binds protons and neutrons that produces or that forms nucleus and also forms atoms that is that which also form a matter. So those are the fundamental forces. Okay, so those are the fundamental forces: the gravitational force, the electromagnetic force, the weak interaction, and last is the strong nuclear force. So these are the basic or the fundamental force. Okay, so in forces there are two main types of forces: the the contact and non-contact forces. So we have two types of forces: the contact and non-contact forces. So from the word itself, contact and non-contact, when we say contact, then there is a direct contact to the object. So contact, there is a direct contact to the object. And when we say non-contact forces, okay, these are forces without a direct contact to the object. Okay, so non-contact, it has no direct contact, while contact forces, it has a direct contact to the object. So first, let us proceed with the so first let us proceed with the non-contact force. Okay, so non-contact force, okay, so non-contact force is part of the fundamental forces. So it is one of the fundamental forces. Okay, so it is the reason why if we jump in a trampoline, you will pull downward, and when you jump on an airplane or in a helicopter, so when the skydivers jump from an airplane or an helicopter, so they are pulled downward. So it is because of the fundamental force, which is the gravitational force. So if the gravitational force or gravity pulls us, so that is the non-contact force, which is the force due to gravity. Okay, so force due to gravity. And it is also the reason, okay, force due to gravity is also the reason why I mentioned earlier that even though you are just sitting on the chair while listening to our discussion, or even though you are just sleeping on the bed, or you are just sitting on the sofa doing nothing, watching TV, or you are just standing doing, okay, you are exerting force. It is because of the force due to gravity. Okay, so this is the reason why you are exerting force even though you are doing nothing, because it is because of the force due to gravity by the means of your weight. So by the means of your weight, you are exerting force to the ground, or you are exerting force to the surface. Okay, the force due to gravity. is the force exerted by the object to the surface. So the force due to gravity, I repeat, the force due to gravity is the force exerted by the object to the surface by the means of its weight. Okay, so for example, if you are if you are sitting on the chair, okay, so at this moment you are sitting on the chair. So if you are sitting on the chair, you are exerting force to the chair by the means of your weight. And that is what we call the force due to gravity. So by your weight, you are exerting force to the chair by the means of force due to by force due to gravity, you are exerting force to the chair by the means of your weight. And to solve for your weight, just simply multiply your mass times the acceleration due to gravity, which is equal to 9.81. So that is the force due to gravity. So, okay, so the force due to gravity is the force exerted by the object to the surface by the means of its weight. So to solve for the weight of the object, just simply multiply mass, which is in kilogram, and acceleration due to gravity, which is equal to 9.81. So the symbol of weight is in kilogram. But since weight is equal to mass times gravity, and also weight, if your weight exerts force to the ground, okay, if the object exerts force to the ground, that is what we call the force due to gravity, which is also equal to the weight, which is a symbol of F sub G. So if the object is exerting force to the surface, so that is what we call the force due to gravity, which has a symbol of F of G, and the SI unit for force. Okay, so the SI unit for force is a capital letter N, which is Newton. And take note, force due to gravity is equal to your weight, or force due to gravity is equal to the weight of the object. So if force due to gravity is equal to the weight to the object, then force due to gravity is also equal to mass times acceleration due to gravity. So that is how to solve for the force due to gravity, or the force exerted by the object to the surface. Okay, so let's try using this equation in a example. So kindly read the questions below.
What is the weight of an object which is 60 kilograms on Earth?
Okay, so we're done reading. Okay, so let's proceed first with the first question. Okay, what is the weight of an object which is 60.0 kilogram on Earth? So since we are talking about the weight of an object, so we are just referring to the weight nor to the force due to gravity. So since it is only the weight of the object, so the unit is in kilogram. But if we are talking about the force due to gravity, then um, the unit or the standard unit is in Newton. Okay, so what is the weight of an object which is 60.0 kilogram on Earth? So if the mass of the object is 60.0 kilogram and the gravity or the acceleration due to gravity on Earth is equal to 9.81 meters per second. So using the equation of rate, mass times gravity, so 60 times 9.81, so that is equal to 588.6 kilogram. So since the least number of significant figure is only 3, so we round this to 3 significant figure, and that is equal to 589 kilogram. So the weight of an object with a mass of 60 kilogram on Earth is equal to 589 kilogram. Okay, next. Second question. What could be the weight of that object when it is what could be the weight of an object when it is on the moon, where the gravity is 1/6 of the Earth? So if the gravity of the moon is 1/6 of the Earth, we just simply divide the gravity of Earth by 6. So using the equation mass times gravity, mass is equal to 60. Then the gravity of the moon, we just simply divide the gravity of the Earth by 6, which is 9.81 divided by 6. Okay, so 588.6 divided by 6. So 60.0 times 9.81, that is 588 divided by 6. That is equal to 98.1. So the least number of significant figure is 3. So sir, hindi na ba i-include si 6 since it is a constant? So hindi natin siya i-include. So 3. So 98.1 has 3 significant figure. So the answer is 98.1 kilogram. Okay, for the third question. What is the mass of that object on the moon? So since the mass of the object doesn't change regardless of its location, okay, so the object's mass does not change regardless of its gravity. So if its mass on Earth is 60 kilogram, so the mass of that object on the moon is also equal to 60 kilogram. Because the mass of an object doesn't change regardless of its gravity. And for the last question, what is the difference between mass and weight? So as I have mentioned kanina, the mass of the person or the mass of an object doesn't change regardless of its gravity. But the weight of a person or the weight of an object changes as the gravity changes, since weight is directly affected by the gravity. So the difference between mass and weight is that weight is directly affected by gravity, while mass is not affected by gravity. Okay, so that's for the non-contact force. So that's it for the non-contact force. So far, do you have any questions or clarifications? Okay, do you have any questions or clarification? Okay, if none so far, then let's proceed with the contact forces. Okay, the contact forces. So the contact forces, so as I have mentioned kanina, it has a direct contact to the object. So contact forces has a direct contact to the object. So the first contact forces or the first contact force is the tension. So tension is the first contact force on our list. So tension is transmitted or it is applied or um it is applied. So tension is applied through a strings, a cable, a chain, or any similar we call this any similar one-dimensional continuous object, and it can also be applied through the end of a rod or any similar uh, three-dimensional object. So it is applied through an object by pulling or pulling force that is transmitted to that particular object. Okay, so it is uh, described as a pulling force transmitted through a string, a cable, a chain, or any similar one-dimensional continuous object, or by the end of a rod, a truss member, or any similar three-dimensional object. So it is described as a pulling force because there is a pulling force applied in each end of this object. So there is a pulling force that is applied to the uh, tails of this object. So a pulling force is applied. Okay, I repeat, a pulling force is applied to each end of this object. So it is also called as a, so this is an example of a tension. Okay, so it is also called as an action-reaction pair of forces. So it is also described as an action-reaction pair of forces acting at each end of the said object. Okay, so for example, in this case, in this pulley, so for tail 1 and tail 2, so tail 1, so in tail 1, there is an object hung on the tail 1, which is the object A, and on tail 2, there is also an object hung on tail 2, which is the object B. So in object A and object B, so there is a pulling force transmitted to the strings, which is by the tails of each, which is on the tail of the string. So in tail 1, there is a pulling force, which is the weight of the object A. And also for tail 2, there is a pulling force transmitted to the string, which is the weight of the object B. So that is why it is described as a pulling force transmitted to the object. And also another example of tension or a pulling force transmitted to the tension is when you are playing a tug of war. So I think you already experienced playing tug of war. So in tug of war, so if this is the rope, so if ito yung rope, there is two groups at the end of the rope. So there is group A and group B. So in group A, they are pulling the rope to the left. And in group B, they are pulling the rope to the right. So, okay, so there is an action-reaction pair of forces in this rope, because if group A pulled the rope to the left, group B also pulled the rope to the right. So there is an action in A and also a reaction for group B. That is why it is described as an action-reaction pair of forces. So tension is a pulling force transmitted through an object. So that is the first example of a contact force. Okay, so the second contact force. Okay, the second contact force is the normal force. Okay, so normal force is it is connected to the third law of motion. Okay, it is connected to the third law of Newton's law of motions. Okay, so it is connected to the third Newton's law of laws of motion, which is the law of interaction. So in the law of interaction, it states that in every action, there is an equal or opposite reaction. So that equal or opposite reaction that is applied to the surface, okay? So if you can still remember, on the non-contact force, so if this is the surface, and there is an object, okay, so there is an object on the surface. So this object is exerting force to the this object is exerting force to the surface, which is the force due to gravity by the means of its weight. And force due to gravity is directly downward, okay, to the surface. So it is vertically downward to the surface. So if this is force due to gravity, which is directly downward, okay, so force due to gravity is the force exerted by the object to the surface, and the equal or opposite reaction of the surface, okay, so if the object is exerting force to the surface, so there is also an equal or opposite reaction of the surface to the object. So there is also a force that is exerted by the surface to the object, and that is what we call the normal force. So the normal force, or a symbol of F sub n. So the normal force is the force exerted by the object, by the surface to the object. And take note, normal force is always perpendicular to the surface where the object contacts. Okay? So it is always perpendicular to the surface where the object contacts. So the normal force is the force exerted by the surface to the um, object, and it is always perpendicular to the surface. Okay, so sir, how can we identify the value of normal force? So there are two instances where we can identify the value of the normal force. So first is, okay, so first instance is if the object is horizontal to the ground. If the surface is parallel to the ground, or it is horizontally if it is horizontal, it is on horizontal, or it is parallel to the ground. So if this is the case, so let us label this as image A, then this is image B, and this is image C. Okay, so as I have mentioned kanina, the force due to gravity or the weight of the object is um, always the movement of the force due to gravity is always downward. So it is always downward. So that is the force due to gravity. It is always downward. Okay, the direction is always downward of your force due to okay, the force due to gravity is always um, downward. Okay, so that is the force due to gravity. Okay, so how can we determine the value of our, or how can we determine or identify the value of our normal force? Okay, so there are two ways to identify the value of our normal force. Okay, so first is on this um, uh, first image, so the image A. So if this is the situation of your object, so if your uh, normal force is directly opposite to your force due to gravity, okay, so the black arrow is your normal force, so this is your normal force. It is always perpendicular to the surface. So this is your normal force, which is perpendicular to the surface. Okay, this is your normal force. Take note, normal force is always perpendicular to the surface. Okay, so for image A, if your normal force is um, directly opposite to your force due to gravity, then your normal force is equal to your force due to gravity. Okay? So if your normal force is, so this is for image A. If your normal force is directly opposite to your force due to gravity, then the normal force is equal to the force due to gravity. But if this is the case for image B and image C, so, so as you can observe, the surface is elevated from the ground. So if this is your ground, there is an angle elevation, which is angle theta. So there is an angle of elevation, which is angle theta. So if this is the case, then the normal force is not directly opposite to your uh, force due to gravity. So if that is the case, if your normal force is not directly opposite to your force due to gravity, then the normal force is not equal to your force due to gravity. So this is for image B and image C. So since it is elevated from the ground, so the normal force is not equal to the force due to gravity. But if your normal force is directly opposite to your force due to gravity, then your normal force is equal to your force due to gravity. Okay? So, sir, how can we identify the value of our normal force if it is not directly opposite to the force due to gravity? So, later we will discuss that on how to identify normal force if it is not equal to the force due to gravity. But for now, we will just first describe what is or discuss what is a normal force. So later we will describe or discuss how to identify normal force. Okay, so that is the contact force, the normal force. So first we have the tension, and then second we have this normal force. Okay, next, after tension and normal force, we have the applied force. So applied force, the word applied, then it simply means it is applied to an object. So a force that is applied to an object by a person or another object. Okay, take note, it is not only limited to a person. It can also be applicable by another object applying force to an object. So that is applied force. So applied force, intuitively, we will think that applied force is by the means of push or pull. So siguro ito ang una nating maiisip when we are talking about applied force. But as I have mentioned kanina, applied force is not limited to person applying force to object. It can also applicable by an object applying force to another object. Okay, so that is applied force. So this is an example of an applied force. A man is pushing a box across the room. Then there is an applied force acting upon the object. So the applied force is the force exerted on the box by the person. So that is applied force. Okay, so that is one of the contact forces. The next, okay, for next contact force, we have the frictional force. Okay, so the frictional force, okay, frictional force is produced, or so it is produced by sliding two surface against each other. So it is generated by two surface that is that contacts or slides against each other. So that is what we call the frictional force. And frictional force has friction. Okay, friction has two types. Okay, there are two types of friction, which is the static friction that keeps an object at rest, and the kinetic friction, which is the force acting on a moving object. Okay, so this force is generated by two surface contacts or slides against each other. So I repeat, the two types of friction. So we have the static friction, a friction that keeps an object at rest, and the kinetic friction, so a friction that keeps a force acting on a moving object. So the symbol of frictional force, or um, the symbol of frictional force is F sub F. So this is the symbol of frictional force. So for frictional force, we can solve frictional force using the coefficient of static friction or kinetic friction multiplied by the normal force. So to solve for the frictional force, we can identify the value of our frictional force by simply multiplying the coefficient of static or kinetic friction. So for static friction, we have the mu sub F, and for kinetic friction, we have the mu sub K, multiplied by the normal force, which is the F sub N. So that is, these are the two types of friction, the static and the kinetic friction. So let's try solving frictional force by using these equations. So the static friction and the kinetic friction. Okay, so for the first example, okay, a 25-kilogram chest is resting along, okay, so it is resting along a rough horizontal surface. Okay, take note, it is along a rough horizontal surface. Okay, the mass is equal to 25 kilograms, and the frictional force or the force due to friction is equal to 75 Newton. So what is the coefficient of static friction between the chest and the surface? Okay, so the question is, what could be the coefficient of static friction between the chest and the surface? Okay, so since we are looking for the coefficient of static friction, so we will use the equation for static friction, which is F sub F is equal to mu sub S times the normal force. So since we have the value of our frictional force, we only need the normal force. So since we do not have the value of our normal force yet, then we will identify the value of our normal force by simply getting the weight of our object. Since the normal force is equal to the weight of the object or equal to the force due to gravity. So sir, bakit siya naging equal to the force due to gravity? Okay, so it is equal to the force due to gravity since the object is lying along horizontal surface. So if this is the object, so this is the object, then this is the horizontal surface. Okay, the force due to gravity is always, the direction of the force due to gravity is always downward. So this is our force due to gravity. And then our normal force is perpendicular to the surface. So if this is our surface, so the normal force is perpendicular. So this is our normal force. So since our normal force is directly opposite to our force due to gravity, the normal force is equal to the weight or simply equal to the force due to gravity. And if it is equal to the weight, then we will use the equation of weight, which is equal to mass times gravity. So mass is equal to 25 kilogram times gravity, which is equal to 9.81. Okay, so if we multiply these two, that is equal to 245.25 Newton. And that is our force due to gravity. So if normal force is equal to the force due to gravity, then we can use the value of our force due to gravity as the value of our normal force in our equation. F sub F is equal to mu sub S times F sub N. So our F sub F is equal to 75 Newton. Then the mu sub S is unknown. The F sub N is equal to the F sub G, which is 245.25. Okay, so divide both sides by 245.25 Newton. So if we divide mu sub S times 245 divided by 245, that is equal to mu sub S. And then 75 Newton divided by 245.25 Newton. Cancel ang Newton. So mu sub S is now equal to 0.3581 and so on. So based on our given, so 75 Newton and 25 kilogram, the least number of significant figure is only 2 significant figures. So we round this to 2 significant figure, and that is equal to 0.31. So the coefficient of the static friction is now equal to 0.31. Okay, what will be the frictional force if a 30 kilogram baggage is moved with a constant velocity along the floor? So the coefficient of the kinetic friction between the floor and the baggage is equal to 0.20. Okay. So in this case, we are looking for the frictional force or the F sub F. So we are looking for the frictional force or the F sub F. So we have the value of our kinetic friction, which is the 0.20. So this is our mu sub K. So 0.20 is our mu sub K or the static coefficient of kinetic friction. So 30 kilogram is the mass of our baggage. So this is the mass of our baggage. So what could be the frictional force if it is along the floor? So if this is the floor, then the baggage is at the top of the floor. Then it is moving at a constant velocity. So there is an applied force. Okay, so the mass of the baggage is 30 kilogram. So there is a mass, then therefore there is a force due to gravity, which is also equal to the weight of the baggage. And then, so if there is a force exerted by the baggage to the surface, so there is also a force exerted by the surface to the baggage, which is perpendicular to the surface. So this is perpendicular to the surface, and that is our normal force, which is the F sub n. So F sub n is perpendicular to the surface or to the floor, which is the force exerted by the surface to the floor. So since our F sub n is directly opposite to our F sub g, then we can say that F sub n is equal to our weight, or also equal to our F sub g. So F sub n is equal to our weight and also equal to our F sub g. Then we will convert our mass to obtain our weight, since normal force is equal to its weight. So to do that, we'll apply mass times gravity. So mass is equal to 30 kilogram. Gravity is 9.81 meters per second. So if we multiply these two, the force due to gravity is equal to 294.3 Newton. So using the equation for the kinetic friction, so this is not U sub S, this is U sub K, since it is the kinetic friction. So F sub F is equal to mu sub K times F sub N. So since we are looking for the frictional force, the value of our mu sub K is equal to 0.20 times the normal force, which is equal to the force due to gravity. Okay, so 0.20 times 294.3 Newton. That is equal to 58.86 Newton. So since we only have one significant figure, which is the 30 kilogram, it only has one significant figure. So we round 58.86 to one significant figure, and that is equal to 60 Newton. So the frictional force of the floor to the baggage is equal to 60 Newton.